Good morning to all. So here we are at last part of our topic switchgear. It's part 6. So in this we will learn about ELCB, that is earth leakage circuit breaker, or interchangeably it is also known as RCCB, residual current circuit breaker. So what is ELCB and RCCB? ELCB is earth leakage circuit breaker, whereas RCCB is residual current circuit breaker. ELCB operates on voltage. It is a voltage operated device, whereas RCCB is current operated device. ELCB measures the voltage in earth wire or ground wire to trip the circuit, whereas RCCB measures the sum of currents in neutral and phase wires to trip the circuit. So nowadays the ELCBs are obsolete, they are not in use, only RCCBs are being used. So they are used to protect the humans from leakage currents. They are available in ratings of 10 amperes to 100 amperes. 2-pole RCCBs are used for single-phase circuits and 4-pole are for 3-phase circuits. They can detect leakages of milliampere currents. As human beings can sustain an electric shock up to the extent of 30 milliamperes, up to 10 milliamperes only a prickling sensation they may evoke, but after 30 milliamperes it may lead to serious shocks. So RCCBs are used to track these higher changes in residual currents up to 300 milliamperes. So here's the working. Under normal conditions, the magnitude of current flowing through phase and neutral wire is same because there is only voltage drop in the load. So under normal conditions, the current should be the same in phase and neutral wire. So the transformer core, which carry both these wires, it should not carry any flux in this case, and no EMF does get induced in the operating coil. When there is an earth fault or there is a leakage current, then this current will get imbalanced. Then the current in phase and neutral wire will not remain same. Therefore, this change in current will lead to the flux generation in the core of the transformer. As a result of this, EMF will get induced in the operating coil, which will further operate the relay and the contacts will get open. So what's the principle behind RCCB? Basically, it works on the principle of Kirchhoff's law, which states that the incoming current must be equal to the outgoing current. So this very principle we are using in RCCB. So it will compare any difference in current values between live and neutral wire. Ideally, this current should be the same. In case of normal conditions, it should be the same. But in case of any fault, the current from the neutral wire will be the different from the current flowing in the phase wire, which is known as residual current. So this residual current is detected by RCCB and the circuit will get triggered. So the test circuit is there to ensure the reliability of RCCB. So there is test button which is provided on RCCB. So if we want to check the working of RCCB, we just push that button. By pushing that button, the RCCB must get operated. If it is not operated by pushing that push test button, then there is the checking of RCCB required. Here you can see the diagram of RCCB. So here's the live wire. Red color wire is live wire and black color wire is the neutral wire. They both are on transformer core. So in case of normal conditions, the current through both these wires is same. So no flux get induced in the transformer core. In case of any fault, in case of any residual current, this current gets imbalanced and the transformer core, the EMF will get induced in this transformer core. And you can see there is one operating coil, residual current sensing coil. This is operating coil. It is also on that transformer core. So in case of imbalance of currents, this residual current sensing coil will detect that imbalance and it will operate the relay, because in case of imbalance there is a flux in the core and then the EMF will get induced in this coil and it will operate the relay and opens its contact. Now you can see there is a test push button. So if we push this button, basically what this push button is doing, you can see the one end is connected to the neutral wire and the other end is connected to the phase wire, and there is this small resistance connected between these two, you can say these two ends, because by pushing this button we are short circuiting live and neutral. So there will be a short circuit occur, but we just want to flow some current of milliamperes just to test it. So we have connected one resistance in series with that test push button so that the current which is required should flow through the transformer core. Otherwise there will be the short circuit. So this test, by pushing this test push button, the ELCB should get operated. If it is not operated, then further inspection on ELCB or RCCB is required. So here it is RCCB. You can see there is a knob for its operation. It's 2-pole RCCB, and you can see in blue color it is test push button. So it is all about RCCB.